Hi kids, here comes objective 5. This is kind of a fun lesson, but for other students, sometimes it makes them crazy because it feels like they're overthinking something really simple. For this objective, knowing that decimals that terminate actually repeat the digit 0, we're going to think really hard about the number 0 and how that relates to terminating decimals, which actually don't exist. Now, if you were here in class, this probably made perfect sense to you. If you were absent, this would be a very difficult lesson to learn just from the copy of the notes that I would have provided to you when you returned. So this is a necessary lesson for you to go back and watch. So I'm glad you're here. So we are going to approach this topic from 3 different ways. So one, there's a second way towards the bottom, and then at the bottom, or at the back, it says a third way. So that will help you keep organized here. All right, let's get really basic here. How many hubs do I have? 1, 2, 3, 4, 5. This is a counting lesson. Not really. How many? 3. How many? I have nothing. Blank, right? The number that we use to represent nothing, no things, blank space is 0. It's kind of like stating the obvious, right? So these questions, it says what comes after the 5 in the number 2.5. Let's just say that I write 2.5. What did I write after that 5? Well, I didn't. I wrote nothing after that 2.5. I picked up my pen and I moved on. I wrote nothing. And what could I use to represent nothing if I had to write a numerical digit? It would be 0. So if I say that there's nothing over here but blank space, I could represent that nothing with a 0. And now I could say to the right of this digit 0, there's nothing over here but blank space. And what can I use to represent nothing? 0. And after that digit, there's just nothing but blank space. And that's nothing. What do I use to represent nothing? 0. And so this goes on. It's very cyclical. I could have this conversation with myself for the rest of my life and have never-ending zeros. So therefore, that is one way to show that 2.5 is, which is a terminating decimal, is also the same as 2.5 with a 0 that repeats. Now here's a second way to think about it. Let's say I would like to expand the length of my number without changing its value. What digit can I add to this without changing what it is worth? Of course, I can add a 0, because this is the same as 2 5/10, which simplifies to 2 1/2. Now this is 2 50 hundredths, which is the same as 2 1/2. This would be the same as 2 500 thousandths, which is the same as 2 1/2. This would be the same as 2 5,000 10,000ths, which is the same as 1/2. Again, I could go on and on and on, and this 0 represents no value after that last digit of 5. And so 0 doesn't change its value. So the top shows that nothing is represented by 0, so I can add 0 to represent that nothing. And down here we can say that we can change the length of a number by adding zeros, and it doesn't change its values. One interesting thing that we brought up, say if you're talking to a young kid and you ask them which number is bigger, they would likely say this one because it is physically bigger, it's longer, but now we know that these are the same because 0 isn't going to change its value. All right, as if we haven't overthought that enough, let's keep overthinking it. There's a third way. I'm sure there's more of them too, but this is the third one that we talked about in class, and it has to do with long division, and this is typically the reaction I get from students when I mention long division. We've kind of suppressed those memories. It's tough. Long division is hard to learn when you're a kid. All right, 2 goes into 5 2 times. 2 times 2 is 4. 5 minus 4 is 1. And we could say 2 remainder 1, or we can keep going. Add a 0, bring it down. 2 goes into 10, 5 times. 2 times 5 is 10. 10 from 10 is 0. Now typically we would be done, but if we wanted to, because long division is so much fun, put another 0 here, bring it down. 2 goes into 0, 0 times. 2 times 0 is 0. 0 from 0 is 0. That was so much fun. Bring down another 0. 2 goes into 0, 0 times. 2 times 0 is 0. 0 from 0 is 0. And you could keep going forever. We're not going to do that. But just to show you again, this is a cycle. It's another way to demonstrate that 2.5 is equal or the same as 2.5000. And also, again, 2.5, a terminating decimal, can be expanded to 2.5 and zeros endlessly, and they are the same thing. So, the big point, the major point, put a star by this. This is the main focus of the whole lesson. Any repeating decimal, terminating decimal, sorry, getting ahead of myself. Any terminating decimal is actually a repeating decimal. There's no such thing, I guess, as a terminating decimal if you really think hard about it, because it actually repeats 0. Now, practically, would we write this? If your answer were, for example, 0.7 as a solution, you wouldn't write 0.7 and endless zeros, right? That would be redundant. But is it helpful for us to think hard about numbers and how they make sense and how we can manipulate them and learn that way? Occasionally, that's good for us to do. Do we do it often? Nope. But for today, that is what we are going to challenge our brains with. All right, so that's a short and sweet lesson. We obviously don't want to dwell on that forever. It's good to talk about it, but not to camp there forever. There's a little bit of a practice for you, just to force you to articulate that. There's a value in restating what you have learned. So I would like for you to choose any of those 3 strategies. Again, they are specified in your notes. There's one way, a second way, and a third way on the back. And I'm interested in knowing which of these strategies resonated most with you, which one made more sense to you. And you can demonstrate how you've understood the skill either in writing, there's some lines here, mathematically here, you can do a combination of the both. So pretend that you're trying to explain this to a peer who hasn't heard this lesson before. How would you explain the fact that terminating decimals actually repeat? They actually repeat 0, if that helps you. Now, if you'd like an extension, when you're finished, you can go back and you can prove that in yet another way. Again, we covered 3 in class. If there's a 4th or 5th way that you would like to propose, I would love to hear it so we can build on your ideas too. All right, if you are lost, if you need some help, do not hesitate to reach out to me here. I am always happy to help. And of course, you know where you can find me at school. I will see you in class. Thanks, guys. Bye.